Hello boys and girls, my name is Wesley Files and I will be your instructor today. Today we'll be learning about momentum. What's momentum, you ask? Well, let me show you.
Peterson to the edge. I mean, we can talk about the speed, the quickness, but this is brute power right here. He just runs over Al Harris. Wow. Yeah.
Interesting, huh? Momentum is a combination of inertia and velocity. The momentum of an object is conserved in the absence of external forces.
If we consider a mass that doesn't vary over time and is subject to a constant force too, the quantity of movement will be the product between the velocity and mass. According to Newton's second law, if a force F is applied to a mass m, the last one acquires an acceleration a. In accordance with the expression, force equals mass multiplied by acceleration.
I'm back again. Now on to my favorite part of the lesson, collision. There's two different types, elastic and inelastic. Woo! First off, an example of elastic collision.
Okay.
In elastic collision, no heat is generated and no damage is done, but instead they bounce off of each other and do not deform. I hope you enjoyed that one. Now, inelastic collision, baby. Woo! In inelastic collision, objects collide and permanently become disformed. In this situation, heat is generated. Another type of collision is explosion. Explosion is when two or more objects push off each other.
If we multiply both elements by the time that the force is being applied, for we get force time variance equals mass by acceleration by time variance. Since acceleration by time variance equals parity of velocity, we have that force by the variance equals mass by velocity by variance, which means that impulse equals force by time variance. An example of impulse could be a tennis player hitting a tennis ball with a racket. The racket, when hitting the tennis ball, will generate an impulse for a short amount of time. Let's watch a video. Law of conservation of momentum. The law of conservation of linear momentum is a fundamental law of nature, and it states that the total momentum of a closed system of objects which has no interactions with external agents is constant. One of the consequences of this is that the center mass of any system of objects will always continue with the same velocity unless acted upon by force from outside the system. An example of conservation of momentum are the Newton balls.
Alright, so thanks for tuning in. That was the Blancs video for momentum for physics class, and I hope y'all liked it. Alright, man, deuces.